Hello everybody, my name is Marianne Moody, and today I'll be discussing site characterization potential for geologic carbon capture and storage in the Fort Worth Basin of Texas. As many of us know, Texas has a quickly growing population. With population growth, we see large increases in industrial processes and increased electricity generation. Both of these processes produce considerable carbon dioxide emissions, which affect climate warming. Geologic carbon capture and storage is the process of taking these carbon dioxide emissions and storing them in geologic media, and is seen as an essential process needed to reduce carbon dioxide emissions. Therefore, the objective of this study is to use site screening and ranking methods for various geological and economic factors to determine what sections and units of the Fort Worth Basin hold the highest potential for carbon capture and storage, especially geared towards major power generation stations. As we can see, the Fort Worth Basin, located in north central Texas, has many power generation station locations, but most of them are located in the northeast portion of the basin. For the purpose of this study, the Fort Worth Basin is split into 5 sections based on tectonic history and subsidence patterns throughout time. These sections are further split into units, with each unit being split into geologic ages, which are representative of a specific subsidence pattern. These groupings are the Cambrian Ordovician, the Mississippian, and the Pennsylvanian and Permian, which are grouped together. If we look further into our stratigraphy, we note that the Fort Worth Basin has 3 major lithologies. Those are sandstone in yellow, limestone in blue, and shale in orange. For geologic carbon capture and storage, we typically target porous and permeable media. In the case of our study area, this is limestone and sandstone. However, shale also plays an important role as it acts as a seal, preventing injected CO2 from escaping back into the atmosphere. Lithology is one of the few geologic criteria that we use in our site assessment. We also use economic factors such as accessibility to storage, infrastructure that's already in place for CO2 storage, and proximity to CO2 sources. Each of these criteria can be assigned a class or a J value, with lower values being least favorable and higher values being most favorable. These can also be assigned a weight. Using both the J values, weights, and the total number of classes, we can input these values into our formulas for suitability calculation to produce an overall ranking value, which ranges from 0 to 1, with 1 being the best. In our results, we note that we have our J values for each section and unit assigned here, and along with our weights and our maximum values for each section, we can note our suitability values. We can see that the Pennsylvanian and lowermost Permian overall has the best suitability values for any of our units, with the Mississippian having the second best suitability values overall, and the Cambrian Ordovician having the worst. The best suitability value that we note is in section 1 for our Pennsylvanian and lowermost Permian units at 0.63. For our conclusions, we determined that the Pennsylvanian and lowermost Permian of the northeast section of the basin has the highest suitability in section 1 with a value of 0.63. We also note that suitability decreases with depth based on our physical characteristics, in the Cambrian and Ordovician especially, showing the lowest suitability for all sections. This is due to changes in lithology, hydrocarbon potential, and maturity. Future directions for this research will use well log data from the northeast section of the basin to perform lithologic correlation of units to find potential CCS reservoirs. We'll also make storage capacity estimates and refine storage capacity estimates for this study. I'd be happy to answer any questions in the comments down below. Thank you for listening.